Hello everyone, this is the lecture on fuzzy set operations. Here we are trying to cover almost all the operations that we can perform with fuzzy set. Myself Dr. DIBYA JYOTI BORA. Okay, you find my introduction in the description of this video. Let's come to the first operation. Now, first operation is that when we can say that two fuzzy sets are equal or not equal. Okay, say AX and BX are the two given fuzzy sets with respect to their membership functions mu AX and mu BX. Then we'll say that AX is equal to BX when their membership grades are equal for all the values of X. This means if mu AX is equal to mu BX, then we can say that AX is equal to BX. Otherwise, AX is not equal to BX. Okay, let's come to an example. We have considered two sets. AX is x1 0.2, x2 0.5, xt 0.1, and bx is x1 0.2, x2 0.3, xt 0.5. Okay, you know that 0.2 is the membership grade of x1, 0.5 is the membership grade of x2, and 0.1 is the membership grade of x3. Similarly, for bx, 0.2 is the membership grade of x1, 0.3 is the membership grade of x2, and 0.5 is the membership grade of xt. Now, just for recalling the membership grade definition, that 0.2 as a membership grade of x1, we mean that x1's participation towards the set AX is 0.2. That is a value lying in between 0 and 1. Okay, if you compare these values, that is for x1 element, the membership grade of this element in AX is equal to membership grade of this element in BX. Mu A of x1 is equal to mu B of x1, but mu A of x2 is not equal to mu B of x2, and mu A of xt is not equal to mu B of xt by just comparing these values. So this means that mu AX is not equal to mu BX for all the elements. Hence, we say that these two sets are not equal. Now, coming to another example, that is this one. Here AX x1 0.1 and x2 0.7, xt 0.8. okay, then bx x1 0.1, x2 0.7, xt 0.8. Sorry. So if we compare this value, for x1 these two values are equal, for x2 these two values are equal, for xt these two values are equal. Hence we can say that AX is equal to BX. Okay, so I hope this equality is clear to you. Now, coming to the next operation. Complement of a fuzzy set. Say AX be the given fuzzy set with respect to the membership function mu x A. Now, its complement will be A dash x, complement of mu x, when complement of mu x is equal to 1 minus mu x. Okay, so it will be more clear through the example. I am considering this fuzzy set AX x1 0.7, x2 0.8, x3 0.2. okay. Now A dash x, according to the definition, what should we have? That is 1 minus mu x for all the x values. So x1 1 minus 0.7, x2 1 minus 0.8, xt 1 minus 0.2. That is x1 0.3, x2 0.2, xt 0.8. Okay, we are just subtracting this value from 1, then overall we get the complement of this given fuzzy set. Okay, so complement is clear. Now coming to the intersection of fuzzy sets. By intersection we usually mean the common value. Okay, let's see how we define intersection in fuzzy set. Let AX and BX be the given fuzzy sets. Then we'll define their intersection as A intersection BX with respect to this membership function, and this membership functions mu x A intersection B is equal to minimum of mu AX and mu BX. Means the membership function will contain the minimum values pairwise between A and B. Okay, means their membership gets minimum value. Okay, let's see an example. I am taking AX is equal to x1 0.7 and x2 0.3 and xt 0.4. Okay, then bx is equal to x1 0.5, x2 0.7 and x3 0.1. Okay, we need to find out the intersection between them. So what we need to do, we need to take minimum of these two values. So A intersection Bx will be x1 and the minimum of these two values, and minimum of 0.7 and 0.5 is what? 0.5. x2 minimum of 0.3 and 0.7, that is 0.3. x3 minimum of 0.4 and 0.1, that is 0.1. Okay, so we are just taking minimum of these two membership grades for the intersection. Okay, so note, intersection is analogous to logical AND operation. Got it? So you do remember this fact, intersection is analogous to logical AND operation. Now coming to next operation, that is union of fuzzy sets. Okay, so considering AX and BX be the two given fuzzy sets, then their union will be A union BX, and the membership function for this union will be defined as mu A union BX is equal to maximum of mu AX comma mu BX. Okay, so now this time we will take the maximum between these two values, just opposite the case of intersection. Considering the same example, means this one AX x1 0.7, x2 0.3, x3 0.4, bx x1 0.5, x2 0.7, x3 0.1. Now we try to find out the fuzzy union of these two sets. Okay, A union bx. So x1 maximum of these two values 0.7 and 0.5. What will be that? That is 0.7. Similarly, x2 the maximum of 0.3 and 0.7, that is 0.7. Then similarly for xt, maximum of 0.4 and 0.1, that is 0.4. Okay, so ultimately A union bx is x1 0.7, x2 0.7 and x3 0.4. I hope this intersection and union operations are clear to you. Okay, so today we have covered 4 important operations, that is first, equality of two fuzzy sets, complement of a fuzzy function, then intersection of a fuzzy, intersection of two fuzzy sets, and then union of two fuzzy sets. Okay, I hope these concepts are clear to you. So now I am giving you some questions. You try to solve them and post the answers by comments. And this is the question. I am giving two sets, AX x1 0.1, x2 0.5, x3 0.9, bx x1 0.8, x2 0.7, x3 0.5. So questions are, find first A, that is whether AX is equal to BX. Okay, the answer will be either yes or no for A. Then find complement of Bx. Okay, you need to find the complement of this fuzzy set Bx. Then A intersection Bx and A union Bx. You can take a snapshot of this. Yes. Then try to solve them and comment the answer. Okay guys, I hope you have enjoyed this lecture, first lecture on the fuzzy operations. Meet you in the next lecture. Till then, take care. Bye bye and thank you.